Hi, welcome to the new chapter, Energy. When you learn something new, of course, the first thing that you should do is to learn the language. So here is a list of different types or different forms of energy, and I want you to find out what the names they are. You may get a reference from the textbook on chapter 4.01, or if you still cannot find out the answer, go and try to Google it yourself. So pause the video now and try it yourself.
A few moments later.
Okay, let's check the answer together. The first one is the energy due to motion. So more precisely, that means whenever the object has a speed that is greater than 0, or it is as long as it's not being stationary, then it has the energy called kinetic energy. So for example, this is an object, and if you move it, then that's the kinetic energy that is it's having. And the faster you move, the more kinetic energy you have. The next one is about the example as in the apples on the tree. So whenever you try to get an object going higher or more away from the ground, because normally whatever object that you have, it will be attracted towards the ground, right, due to the gravity. So that means they have a tendency to go down because of gravity. And so whenever you move an object up, you are actually giving it energy. So this is actually called gravitational. So make sure you can spell it correctly. Gravitational potential energy. And the word potential is actually important because it has the potential to drop due to gravity. So you can't say gravitational energy, you have to say gravitational potential energy. The next one is related to chemical reaction, and obviously it's called chemical energy, or you can also call it chemical potential energy. Again, because it has the potential to release the energy in the form of chemical reaction. So an example could be the glucose in the cell. If you have studied biology, then you should have learned glucose, which is C6H12O6. And when you perform respiration, which is something that you are doing right now, then you need CO2, and it will be converted into CO2. Oh no, not CO2, O2, oxygen, and it will be converted into CO2 and then H2O. Okay, and to balance this equation, you have to do the ratio, multiply 6 here, multiply 6 here, and multiply 6 here. So then, yeah, that's how you can balance an equation in chemistry. Don't worry, this is not something that we will need to ask you in physics. But then the idea I want to show you is when you are breaking the bond of these glucose, because they are bonding in between the carbon and hydrogen and oxygen, right? And so when you break them apart, those energy will be released. So to complete this equation, normally in biology you also put down plus energy, and that is simply the chemical potential energy. Next one, you have learned about Hooke's law earlier, and you know that the basic behavior of a spring is if you try to extend it, it will try to go back to the natural length or the original length. If you try to compress it, it also want to go back to the original length. So when you compress it, that action gives it a potential to restore back. So that is the energy you give to the spring. And so this is called elastic potential. Once again, it has the potential to restore back to the original position. There's another name called strain energy. It's just a name, okay? So yeah, don't ask me why that's the name. That is simply another name, okay? In fact, everything in the world are elastic. It's just they may have different spring constant, or we call elasticity. For example, the ruler here, you can try it as well. You can always try to balance it like this. So when I try to pull it down like this is also elastic potential energy. It doesn't need to follow Hooke's law. Anything that are elastic could have elastic potential energy. Next, if you look at the examples, then you know that it's something to do with nuclear power station or the sun or hydrogen bomb, etc. Then definitely something to do with the nuclear itself. So we'll call it nuclear, again, potential energy, because it has a potential to have the nuclear reaction. So here probably is something that you cannot find on the textbook, and they are the names for the nuclear reaction to happen. So for nuclear power station that we usually have nowadays around the world, there are many different nuclear power stations in many countries, and so that will be one of the source that supply for our electricity. So that reaction is when the atoms will split. We'll call it nuclear fission. Okay, so the elements, if you are wondering what they are using, they use something called uranium-235. Okay, don't worry, you don't have to memorize this. As for the sun, actually the sun is doing something called nuclear fusion. Alright, and probably you have heard about the word fusion before, maybe in a restaurant. For example, the fusion cuisine of, I don't know, Japanese and Indian, okay, I don't know how, curry on sushi, I don't know, I'm just making it up. But then that's the idea, right? When you combine things together, then that's called fusion. And so for the sun, it's actually hydrogen fusing with hydrogen, and this is how it can actually provide you energy. So it's not burning the hydrogen, okay, you have to be very careful. It's actually a nuclear reaction that combines the atoms. Next one you can guess easily from the example, and that is any object above absolute zero. Absolute zero is a temperature where the atoms stop vibrating. It's the lowest temperature we can get, and in case you don't know, it's -273 degrees Celsius. We'll talk more about this in the later chapter, and this obviously is referring to the thermal energy. And the reason why I put down kinetic plus potential energy for micro, here it actually refers to microscopic. Okay, that means using the particle theory. And in fact, they are the same thing. Kinetic energy, potential energy in the microscopic view, using the particle theory, it's the same kind of energy when we see it in the macroscopic view. Microscopic means in what we simply see with our eyes, and we'll see it as thermal energy. Let me explain very quickly. So in an earlier, I think junior secondary, you should have learned about particle theory, and you should have heard about solid, liquid, and gas, right? And you should have learned about how the particles are separated because of the potential energy. The further away they are, they will have greater potential energy because they want to get back. And for kinetic energy, something to do with the temperature, the faster they move, then the greater kinetic energy they have. That's related to the temperature. Again, we'll talk more about this in the later chapter. So these two ideas is simply the same thing. It's just depending on how we see them, microscopically or macroscopically. Next one is very obvious. It's talking about the energy that you transfer from the battery to power up the light bulb. So the energy that carried by electrons is called, of course, something to do with electricity. So electrical potential energy. Again, think about this. When you build a circuit, again, something you probably have learned earlier in maybe primary. Okay, this is a basic circuit, and then you have something called the current coming out, but then the current itself is not expressing or transforming that energy into something else. It's just simply moving across the wire, but then those energy are stored as electrical potential energy. They have the potential to be released, and when they meet maybe the light bulb, then it will be changed, it will be transformed into light energy, for example. So yes, the next one that we talk about is light energy and also sound energy, and they are in a category of something called radiated energy. So what is radiated energy, and why do we put light and sound energy into this category? Is simply think about the light bulb. When you try to switch it on, it go in all direction, right? Same as your loudspeaker right now is going, the sound is going in all directions. So okay, I don't know how to draw, so let's say this is the loudspeaker, so it go in all directions simply. So that's why we call them radiated energy. So here you have it. These are all the energy types that you may have, and you can use these names to describe different forms of energy later on. In the next video on the playlist, I have included another video which tell you more about like using animation on these different forms of energy. So make sure you watch that as well before going for another video of mine. I'll see you again later on. Bye.